Hello there, welcome back to Intro to FortiGate series. This is Module 3, Setup Decisions Part 1. I'm your host, Matt Sharif. In the previous module, we covered the factory reset, WAN and LAN addressing, setting up LAN services as far as DHCP, DNS, and NTP, and setting up a basic policy to get out to the internet. In this module, we're going to go ahead and cover operation mode, whether that's NAT or transparent mode, and whether or not we should use SD-WAN. Assumptions for this module is that you have a FortiGate, whether it's physical or virtual, so you can follow along with the examples, and that you've completed Module 2, Initial Configuration. Now that we have that out of the way, let's get to it. Operational mode basically covers how the FortiGate operates, in that whether we're going to act as a layer 3 firewall or as a transparent layer 2 firewall. And let's stop to talk about that for a minute. So NAT mode is what the folks at Fortinet call the layer 3 operation, and that's where you expect the FortiGate to act as the default gateway for one or many networks. And whether it's a device that's sitting on the edge of your network or it's an internal segmentation firewall, it is actually performing the routing between one subnet to the other, or separating broadcast domains for more OSI-like speak. Transparent mode functions more like a switch in that it actually has MAC address tables, and it forwards packets, or the more proper term, frames, between members in the same broadcast domain, with the very big difference of the fact that you actually have to explicitly tell it that one port is allowed to talk to another port. So let's take a look at the operation mode differences. Alright, well, let's take a look at this in action. First, we're going to take a look at NAT mode. So this is the FortiGate we've been working with the entire time. This is the same device we used in the initial setup video. And as you can see, it is running in NAT mode. NAT mode is going to be the default mode of operation for all the FortiGates. And it, as I mentioned, separates broadcast domains. So you'll have one IP subnet to another IP subnet. You can have multiple IP subnets hanging off of each of these interfaces. You can have multiple VLANs, which are then assigned IP subnets, etc. You can do one form of transparent firewalling in NAT mode, not to confuse things too much. It's called virtual wire pair. Essentially, virtual wire pair is something you would do. Let's say you needed to insert a firewall in line between your edge router and the rest of your network, but you didn't want to change the routing and all the IP schemes and stuff like that. That would be a very good use case for virtual wire pair, while you get everything else configured and prepare to cut over to the firewall at a later date. The way you create a virtual wire pair is you go to Network Interfaces, Create New, Virtual Wire Pair. The rules of creating a virtual wire pair are pretty straightforward. The interfaces cannot have any references to them. Also, that you can only use two interfaces in a virtual wire pair. Traffic can only go from one interface to the other. It cannot go to any other interfaces. This is literally like a virtual wire. So if we take a look at that, and let's say we want to create a virtual wire pair between port 2 and 3, we could say my VWP is a terrible name, but let's just go with that. If you had VLANs being tagged through this, you may want to click wildcard VLAN filter. That way it knows and it can inspect VLAN tags. However, in this case, let's just say it's one flat subnet and there are no VLANs going through there. I'm going to click OK. Now under Policy and Objects, you can find a virtual wire pair policy. This is very useful if there was a device on the network that you maybe wanted communicating one way and you didn't want it, things to communicate back to it. Or if you wanted back and forth communication, you can choose this. And this is very much like setting up a regular policy. So if you were to click over either of these directions, you could see that from internal 2 to internal 3, maybe we don't want to let whatever's hanging off internal 2 talk to anything hanging off internal 3, but anything on internal 3 can talk into internal 2. We could definitely do that. You could even narrow it down to, let's pick on our executives. They're the only ones who should get access to it. And let's just say the destination here is anything coming off of internal 2. Execs. And let's say this is the execs printer. So maybe we do, I don't know, we'll let them use file shares. So we'll do Samba and SMB for that. We're not going to be doing any NAT. That's fine. It's just a printer. I don't want it talking back in. I only want folks to talk to it. And that'll be it. And this is a sample of a virtual wire pair policy. Other than that, NAT mode offers regular routed features. So if we were to go to System, Feature Visibility, and turn on the advanced routing, under Network, now you can see all the routing options we have. So we obviously have the static routes, policy routes. Then we support RIP, OSPF, BGP, and since 7.0, all the routing objects live in the UI as well. So if you needed to create a route map, access list, prefix list, etc., you could create all of these here. I'm still a CLI guy, however, for those of you who understand the concepts but don't necessarily understand the CLI syntax, this may be a good helpful primer for you. Other things you can do in NAT mode or routed mode is you can obviously do SD-WAN, and we'll take a look at this a little later in this video series, as well as VPNs. These are all important layer 3 features. Let's flip over to our transparent FortiGate right now. As you can take a look, one of the biggest differences here, if we look at just the interfaces on the transparent mode, is the fact that we don't have IP addresses listed here. So even if I were to go into the interface here, this internal 1, there's no option for me to set an IP address. And that's because the FortiGate is running in transparent mode and it acts more like a layer 2 switch. The big difference, as I mentioned earlier, is the fact that we have to set policy to allow an interface to talk to another interface. So let's set the stage for a use case here. Let's say this is a training center or a classroom, and while we want all the workstations to talk to the training servers, we don't necessarily want them to talk to each other. Call it, an overly mischievous, Lord knows I was one of those guys who thought it was funny to send a remote shutdown command, or to send net send commands, all kinds of other disruptive stuff you can do. Just, leave it to creative people. So you don't really want those devices talking to each other. You do want them talking upstream, and that's it. So you could create a policy to only allow these devices to talk upstream. For instance, if we take a look right now, I have internal 1 talking to DMZ in my policy. So we take a look at this. Internal 1 to DMZ. My Mac Mini talking to everything. So if we were to take a look at this, at my routing table on my Mac Mini. So this just threw up a lot of stuff. So let's see if we can scroll up and see what we're talking about. So my default gateway, I've got a Wi-Fi connection here, but I've also got a wired connection. So I'm gonna disable my Wi-Fi connection and run that netstat command one more time. Okay, so now my default gateway is only this 10.220.47.1. And if I were to clear this real quick, I'll run a ping ping 10.220.47.1, and this all works great. If I were to just disable this, as if I were to turn off that policy, as you can see, I can stop my communication to the network. So this is going from internal 1 to the DMZ. This is my upstream. This is where the rest of my network lives. This is where I live. And we're all on the same network. So we'll go here, enable, and once we enable that again, we're back in business. So if I do a IP ADDR, okay, so basically, I guess macOS hasn't caught up with the rest of the Nix world. If you take a look, my IP address is 10.220.47.100 with a /24 subnet mask. My gateway, as I showed you earlier, was 10.220.47.1. So we're in the same broadcast domain. So I'm controlling that very, very easily. If I had another device hanging off of another port, we could definitely control that kind of communication traffic. Another place this may be useful is if you have a group of servers. Now, I know most servers aren't single purpose anymore. They are typically used as virtual hosts. So you could end up using this to segment those to ensure that only the devices or the servers that you want, let's say an application server, can talk to your database server and to your directory services server, whether it's AD, OpenLDAP, or whatnot. The idea here is that we can just, really get very granular without having to segment at a layer 3 level. Similar to how a VXLAN overlay can do this, but we're doing this really at layer 2 as opposed to adding yet another overlay. So this is an area that may be helpful for you. Some of the restrictions that you may have with transparent mode is if we take a look, I don't have SD-WAN here. And if I go under system feature visibility, I don't have advanced routing. I don't have anything with VPN due to the fact that this is a layer 2 device right now. He cannot initiate any of those connections. So just be mindful of that if you go to deploy transparent mode. Okay, so I think we've done a pretty basic explanation on NAT mode versus transparent mode. So that about covers it for operation mode. Just remember, NAT mode functions like a router with baked-in security. Transparent mode functions like a layer 2 switch with baked-in security. For more advanced and complex scenarios, I encourage you to subscribe and keep your eyes open for future videos, as we'll cover those in more depth. So let's discuss SD-WAN. Before we go too far into this module, let's actually address what SD-WAN is. A lot of the market would have you believing that SD-WAN involves some sort of VPN overlay. I'm not saying it doesn't. I'm saying it's not a requirement. SD-WAN at its most basic is the ability to steer traffic using software-defined rules. What does that mean? Well, the way we used to steer traffic is we'd have to find out the source IP, destination IP, destination ports if necessary. We'd have to look that all up. Sometimes the source ports, and try to figure out some other characteristics as well. And then it would involve some pretty complex routing rules, starting with probably a prefix list or something like that, and then using a route map to decide which next hop would be best. And even that was fraught with issues. Wasn't always accurate, wasn't always adaptive. Having something like SD-WAN that can identify the application for you and then enable you to steer that is very helpful. It reduces the amount of work that we have to do as admins, and it also frees us up to do the more important stuff. Why would we use SD-WAN? Well, for one, it makes failover between internet uplinks a lot easier. Today, we're seeing that internet connectivity is relatively cheap, and organizations are able to afford connectivity up to the cloud and out to the internet So it's not uncommon to see two ISPs, maybe a third LTE failover. Or the other use case maybe is that you do have two ISPs, and for whatever reason, your Teams connection performs best out of ISP B as opposed to your primary ISP, which is, let's say, it's a gig or whatever, and then the backup is like 250 meg, but Teams connection works better out of that one. So maybe we would want to have all of our primary traffic go out the primary link and our secondary traffic go out, or our Teams traffic go out the secondary link, yet have the ability for it to fail over in the event that the secondary link either fails or is having a bad day. So let's take a look at a basic SD-WAN example. On the FortiGate that we've been using throughout this series, we're going to go ahead and set up a basic SD-WAN rule. For this, we're going to go ahead and use interfaces WAN 1 and WAN 2. Although WAN 2 is down right now, we will go ahead and use it anyway. To enable SD-WAN, in previous versions of code, you actually had to turn on the SD-WAN functionality. If you're using the UI, as soon as you start adding zones and members and add SD-WAN rules, this will enable it for you. If you look under the SD-WAN section, you will see that there are two default zones: Virtual WAN Link and SASE. Virtual WAN Link is the default SD-WAN zone, and SASE, this is for a FortiSASE integration that's coming later on in FortiOS. So I'm going to create a new zone, SD-WAN member, SD-WAN zone, and we're going to call him ISP underlay. And the interface members, hey, wait a second. Okay, we need to create some interface members, and we can start with, where's WAN 1? One of the rules for SD-WAN members, as is for the virtual wire pair, as we discussed earlier, is that interface must not have any references to it. So if we go and take a look at the interface, you can see that there are some references called out here. Primarily is that it's being used by the firewall policy that we outlined and created in the last video. So a quick way to do this, because this is a non-production device, is I'm going to just go ahead and change the outgoing interface to, oh wait, I did not create the zone altogether. So let's go ahead and create that SD-WAN zone, ISP underlay. And yes, with the name ISP underlay, that does imply that at some point we will use an overlay, however not in this video. And we're going to go to the firewall policy. We're going to go ahead and change the outgoing interface from ISP underlay, from WAN 1, to ISP underlay. Now this will be disruptive to traffic, so don't do this to in production FortiGates. Just be mindful of this. Another thing we're going to go ahead and do ahead of time, because if we don't do this now, this can be disruptive. You'll lose your connection to the FortiGate if you're not on the same subnet, which I am not on the same subnet. I am managing this FortiGate through its WAN 1 interface, which is 10.220.27.10, and as you saw earlier in the video, I'm at 10.220.47, so we're in different subnets. So if I go ahead and forget to do this step, I will cut off my arm to this device. So what we need to do is we need to create a default route to the ISP underlay zone. Now you say, hey, wait a minute, timeout. How are you getting to this FortiGate right now? I'm getting to it because it's getting the dynamic gateway from DHCP. However, as soon as I enable SD-WAN and add WAN 1 to that zone, FortiOS is not going to have a route to send traffic out WAN 1. It will have a route for WAN 1. However, WAN 1 is part of the the SD-WAN bundle, and FortiOS is not going to know to send traffic to the SD-WAN bundle. So now I can come here and say, hey, create a new SD-WAN member. We want to add them to ISP underlay, and it's WAN 1. I'll specify that it's dynamic because he's a DHCP connection. If you had a static connection, you would specify this right here. So my cost is going to remain 0 for now because it's a wired connection, and my priority is 1. For LTE, you may want to set your costs a bit higher, as you don't want those getting engaged right away. And as you can see, ISP underlay now is green and it has WAN 1. Another thing I want to point out is we're going to create that WAN 2 member, and he too is going to be a part of ISP underlay, and we'll assume he gets a DHCP gateway as well. And now we have 2 members. If we go over to SD-WAN rules, if I do nothing else at this point, the FortiGate will send traffic out of any available interfaces. In this case, it's only WAN 1 since WAN 2 is down, and it'll load balance them based off of source destination IP, so basically per flow. I don't necessarily like leaving this up to chance, so if I have an LTE connection, he'll invariably end up getting used as well. Even if I were to change my load balancing algorithm to volume and I were to say, hey, WAN 1 is 100 and WAN 2 is 1, some of that traffic will still end up going over WAN 2. Source destination IP is okay for the default. However, first thing we want to do is create a default internet rule, default INET, and as I specified earlier when we were talking, is we want to allow all traffic outbound manually, in this case, basic SD-WAN example, to go out WAN 1 first and then WAN 2. And the order which you click is the order of preference. Okay, we're good there. Now to apply that second use case, and let's say, hey, wait a second, Teams works best on ISPB. So what we can do is say, hey, from LAN destination, you could say you could use the ISDB entry. So you would say, hey, Microsoft Skype Teams. We could do that. Or you could base it off of the application. Microsoft Teams. And say, hey, manually speaking, let's go out WAN 2 first, and if WAN 2 is down, then we'll go out WAN 1, which is what would happen in this use case. The other, these other strategies, we'll go ahead and discuss in a later module. Just want you to know what the basic SD-WAN configuration is. And last but not least, let's talk let's actually move this to the top here. So anything going out to Teams is going to go out WAN 2. Currently, as it's showing you that this member is selected because WAN 2 is down. Performance SLAs go hand in hand with the other strategies that we saw, and I said we would speak about. These actually measure the quality of the connection to a specific resource. If we were to take a look at, hey, let's check AWS. Let's say we had some AWS workloads. Let's go ahead and do an HTTP probe to aws.amazon.com. We would always want to specify the SD-WAN members we want to participate in this, especially if we're using VPN overlays, because it would be very interesting if we tried to probe AWS using our VPN members. One thing to note here is you want to double check whether or not you want it to update your static route. If an interface member, let's say, hey, WAN 1 and WAN 2 in this case, falls out of compliance with this SLA of a latency threshold of 250 milliseconds, jitter threshold of 50 milliseconds, and a packet loss threshold of 5%, then it will remove the static route from the routing table and the secondary member will become active. If there are no members that comply with this, those connections will go down. So just be mindful of this. I'm going to do this for now. And if I just go back here, performance SLAs, as you can see, default AWS. Now it's checking it and it's measuring. And as this updates, you will see the graph update. So WAN 1 is yellow. Hey, look, our latency has been under 50 milliseconds, roughly about 37 milliseconds, fairly standard. Jitter's been about 18 milliseconds with 0 packet loss. Now, right now, this isn't doing anything other than checking the connection, and it would update our static route. We may not want that, so for right now, I'm just going to go ahead and tell it to not update our static routes. And that, in a nutshell, is a basic SD-WAN example. Follow us for further videos, as in our next video we're going to go ahead and talk a little bit about VDOMs and some additional administrative decisions you will need to make when setting up a FortiGate. I'd like to thank you for watching. I hope this was informative and helpful. Madman out.